Hi, thanks for joining me today. I'm going to be going over problem 3 from week 1 of the Michaelmas term 2020 Invariants Maths competition. The Invariants Society is the maths society at the University of Oxford, and they're currently running a competition where every week they release 3 fun maths problems for you to have a go at. I'll leave a link in the description below to the Facebook page of the Invariants where you can find more details of the competition. Anyway, this is the problem I'm going to be tackling today. We want to be able to find all solid convex bodies in 3D space such that the projection onto any plane is a circle. Okay, so firstly, what's a solid convex body? Well, that's just a 3D shape, and the convex part of the word means that if you take any 2 points within the shape, you can always find a straight line between them. Okay, so for example, this shape here is not convex, because if you take these 2 points here, say, the straight line in between them has to exit the shape. However, if you look at like a cuboid, this weird cuboid thing I've drawn here, if you take any 2 points within the cuboid, you can always connect them with a straight line which remains inside the cube. For example, these 2 points here, and the same goes for any 2 points you choose. Okay, and the projection means that if you take a torch, for example, and say shine the torch on this convex body, and then on the other side you put a piece of paper, the shadow that's left on the piece of paper will be a circle. And that's regardless of which way you put the torch. So if you have your paper here and you put the torch here, the shape in between leaves a circular shadow. But if, say, you put the torch here and now the piece of paper here, so it's always opposite the torch, you're always going to get a circle. So regardless of which way you have the torch and the paper, it will always leave a circle. So we want to know which solid convex bodies have this property. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to get stuck into a solution. Okay, so the solution to this problem is spheres. Spheres are the only convex bodies for which whenever you hold a torch at any direction and put a piece of paper directly opposite that torch, you're always going to be left with a circle. Now it's obvious, or somewhat obvious, that spheres definitely are a shape with that property. You take any ball, say, and you shine the torch from any direction, it's going to quite clearly leave a circle as the shadow on the piece of paper opposite. However, the converse is not necessarily quite or as obvious, where if you were to take any shape with that property, it must necessarily be a sphere. But that's what I'm going to prove now. Okay, so suppose we have a shape with this property. So it's a 3D convex body, and no matter where you shine your torch from, the piece of paper you put on the other side, directly opposite the torch, will always leave a circle. Okay, suppose our shape is a cuboid for now, and obviously it won't be a cuboid, but this is just to illustrate something. What we're going to do is take the points on our shape which are furthest away from one another. So if it was a cuboid, it would be, for example, this point here and this point here. So that we can call this thing here A and this thing here B. And obviously AB is the maximal distance between any 2 points on our shape. Now, of course, it won't be a cuboid, but no matter what our 3D convex body is, we're going to do the same process. Find the 2 points which are at maximal distance from one another, call one of them A and one of them B. And now what we're going to do is rotate the shape so we can have A and B like this. So A here and B here. So if it was a cuboid, we sort of rotate it. So now we have A here and B here. And we're going to just draw this line in here. And without loss of generality, we're going to call this thing here, have it at 2 units length. Okay, so 2 units. Now, so we've got our 3D convex body here. I'm deliberately not drawing it because, well, it's arbitrary. It could be anything, and what we want to try and do is show that it must be a sphere. Okay, but for now I'm just going to draw in these 2 points, but think of this as there's a shape here, but I'm only highlighting the points A and B. Then what I'm going to do is shine my torch here first onto our 3D body, our 3D convex body, and well, we know that it's going to leave a circle as our projection. It's going to leave a circular shadow, but we also know that that circle must be, well, because this torch is perpendicular to this line, it must be the circle which is radius 1 or diameter 2. Okay, so I'm shining my torch here. It's going to leave a shadow which is the circle, this thing here, which has the diameter the same as AB. Because obviously, because the torch is going perpendicular to AB, the length of AB doesn't change. And of course we know that it's not going to be a circle of bigger radius, because of how we define A and B to be the maximal distance between any 2 points on our convex body. Okay, but I've shone my torch from here, but the same holds if I shone my torch? if I shine my torch from here, here, or behind, or under here, so we know that no matter where we shine our torch from, provided it's shining perpendicular to the line AB, we're always going to get a circle with radius 1, diameter 2, like so. Okay, so that means, well, if I shine my torch here, for example, we know the projection's going to be within this circle, so then that means that our body must lie, if we think of an infinite cylinder, so to speak, a cylinder extending out this way, and a cylinder extending out that way, with diameter 2, like so, going off to infinity in both directions, we know our body, our shape, our convex body must lie within that cylinder, but it must also lie within this cylinder here, all of the sort of 360-degree angle cylinders you could possibly have. And because we know it's in the intersection, well, the intersection is just the sphere here of radius 1, diameter 2. So we know our convex body must be within the sphere of radius 1. Now what we want to do is prove that it must be the sphere of radius 1, and that's where we use the fact that it's a convex body, because, well, if it wasn't a convex body, then we could, and it wasn't the sphere, then we'd be able to find 2 points on our body, which, when you draw a straight line between them, you wouldn't, it would have to leave this, the body. Okay, so let me just quickly go over what I've done. I've taken my arbitrary convex body, which has the property that no matter where you shine the torch from, you're going to get a circle, and we want to show that this convex body is a sphere. We're going to take the 2 points on that shape, which have maximal distance from one another, and call one A and call one B. Rotate the shape so that AB is like so, and this, without loss of generality, have this thing here 2 units of length. Then when we shine our torch here, we're going to get a circle onto our, as a circular shadow, as our projection, and it's going to look like so, with diameter 2. And that happens whenever you shine our torch from any of these perpendicular directions, and thus we have that our shape must be embedded within this infinite cylinder, this one here, all of the infinite 360-degree angle spheres, cylinders, sorry, and thus the shape must be embedded within the sphere, because the sphere is the intersection of all those cylinders. Okay. Now, I claim that our convex body must be exactly that sphere. Well, if it wasn't, then we'd be able to find 2 points on it, which when we draw the straight line, it would leave the convex body, and hence that would contradict the convex property of the shape. So one example for that is if I took a sphere, but then removed a small sphere from inside. So think of like a donut, but rotated sort of thing, or I guess a football with the air inside, so it's a hollow football. But then, of course, that's not a convex body, because just draw the line from any 2 points, it's going to enter the no man's land in between. I think I'm waffling now. Hopefully that has made some sense. And thus we can conclude that it must be the full sphere of radius 1, so the unit sphere. I hope that proof has made a bit of sense. It's a little bit difficult to explain, especially on a 2D whiteboard. But hopefully you can convince yourself that they must always be a sphere if it's a convex body with the property that whenever you shine a torch from any direction, you're going to get a circular shadow. I hope you have enjoyed this video. If you are new here, please do consider checking out some of my other fun maths videos. I don't just make these solution videos, I make lots of other like problem solving, proofs, that sort of thing. So if that excites you, do consider subscribing and checking out some of those as well. Anyway, I will catch you in the next one. Have a great day.